Hello everyone and welcome to our climate presentation. I'm excited to have you here today. On this first slide, you'll see the title, Climate Presentation. We'll also touch on some key topics related to climate change, its impacts, and what we can do to help. Over the course of this presentation, we'll explore these areas together. So let's get started. Now let's take a look at the contents of our presentation. We will begin with an understanding of what climate is, followed by exploring what weather actually means. We will then discuss the elements that make up weather and climate, including temperature, humidity, and other key factors. Moving forward, we will examine atmospheric pressure, wind, and the climatic controls that influence different regions. We will also delve into the factors affecting India's climate specifically, such as the distribution of rainfall and the different seasons the country experiences. This includes a closer look at the winter season or the cold weather period, as well as the hot weather or summer season. Further, we will analyze the climatic influences of the Himalayas, the onset and withdrawal of the monsoon, and how the monsoon advances during the rainy season. All these topics are interconnected and help us understand the complex climate patterns of India and the broader concept of climate as a whole. When we talk about climate, we're referring to the overall pattern of weather conditions and variations that occur over a large area and, importantly, over a long period of time. It's not just about what the weather is like today or this week, but about the broader trends that shape a region. Climate records include extreme values too, like the highest temperatures ever recorded or the most rainfall in a day. These extremes help us understand the full picture of a region's climate. And when we say long-term climate, we're talking about observations that span at least 30 years. This long time frame allows us to see consistent patterns and make meaningful comparisons. Understanding climate in this way is key because it influences everything from agriculture to infrastructure, and it forms the basis of how we study climate change and its impacts around the world. Weather is essentially the state of the atmosphere at any given point in time and space. It's what you experience when you step outside, whether it's sunny, rainy, windy, or cloudy. One of the key things to remember is that weather is constantly changing. It's a dynamic part of our environment that shifts every moment. For example, you might wake up to a clear sky, but by the afternoon, it could be cloudy or rainy. Some common types of weather include cloudy days, dry or arid conditions, windy moments, and wet weather like rain or snow. Understanding weather helps us better grasp how our environment behaves and influences our daily lives. It's a fundamental part of the bigger picture of climate and atmospheric science that we're exploring in this presentation. Let's take a closer look at the main elements of weather and climate. These are the fundamental factors that shape the patterns we experience day to day and over longer periods. The key elements include temperature, atmospheric pressure, wind, humidity, and precipitation. Temperature is perhaps the most noticeable element. It affects how we feel and influences many other weather aspects. Atmospheric pressure, on the other hand, tells us about the weight of the air above us and helps predict changes in weather. Wind is essentially air in motion, driven by differences in pressure, and it plays a critical role in distributing heat and moisture around the globe. Humidity refers to the amount of water vapor in the air, which impacts comfort levels and the likelihood of rain or clouds. And speaking of which, precipitation covers all forms of water, rain, snow, sleet, or hail, that fall from the sky, completing the picture of how weather interacts with our environment. Understanding these elements not only helps us interpret daily weather reports, but also connects to broader climate patterns. They are the building blocks for understanding how our atmosphere functions and how it influences the climate of different regions. Let's talk about temperature. Temperature is essentially a measure of how hot or cold something is, but more specifically, it reflects the average kinetic energy of the particles within an object. Kinetic energy, as you might recall, is the energy associated with motion. So, when we say something has a high temperature, it means the particles are moving faster on average. Conversely, a lower temperature indicates slower moving particles. This concept is fundamental because it links temperature directly to the energy and movement at a microscopic level. Understanding temperature helps us grasp how energy transfer occurs, which ties into the broader themes of energy and thermodynamics we've been exploring in this presentation. Let's talk about atmospheric pressure, also known as air pressure. This is the force that the air above us exerts on any surface. Think of it as the weight of the air pressing down due to gravity pulling it toward Earth. This pressure isn't just a random force, it plays a vital role in many atmospheric phenomena. To measure atmospheric pressure, we commonly use a device called a barometer. The readings from a barometer help us understand weather changes and other atmospheric conditions. Understanding atmospheric pressure is key because it connects to many elements we've discussed so far, like weather patterns, altitude, and even how our bodies react at different heights. It's a fundamental concept that helps us grasp how the atmosphere influences our daily lives and the environment around us. Let's talk about wind. Wind is essentially the flow of gases, but on a much larger scale than what we experience in our daily lives. When we say wind, we're referring to the movement of air across the Earth's surface. This movement is driven by differences in temperature and pressure, which create these large-scale air currents. Understanding wind is important because it plays a crucial role in weather patterns, climate regulation, and even in how we harness renewable energy through wind turbines. It's a natural phenomenon that connects closely with the overall theme of atmospheric dynamics, showing us how gases move and interact on a global scale. So next time you feel a breeze, remember, it's part of this vast, powerful system of gases flowing across the planet. Now let's talk about humidity and precipitation, which are key components of our atmosphere. Humidity basically refers to how much water vapor is present in the air or in a gas. It's an important factor because it affects how we feel and also influences weather patterns. Precipitation, on the other hand, is what happens when water vapor in the atmosphere condenses and falls to the ground. This includes various forms like rain, snow, or hail. It's also measured by how much water has fallen over a certain period, usually in inches or centimeters. Understanding these two elements helps us grasp how weather systems develop and how moisture moves through the atmosphere. They're essential pieces of the larger climate puzzle, connecting to everything from daily weather to long-term climate trends. The word monsoon actually comes from the Arabic word mawsim, which means season. It's a great example of how language reflects the natural phenomena we experience. When we talk about monsoons, we're referring to the seasonal reversal in wind direction that happens over a year. This shift is what creates the distinct wet and dry seasons we associate with monsoon climates. The climate of India, for instance, is classified as a monsoon type, and this pattern is also typical in South and Southeast Asia. One of the key things to understand here is that the climate isn't uniform everywhere. It varies from place to place and season to season. Temperature and precipitation, those are the two main elements, often change dramatically depending on the region and time of year. So, in the context of our overall theme, understanding the monsoon is crucial because it influences agriculture, water resources, and even daily life in these regions. It's a perfect example of how climate shapes the environment and human activity in a specific area. All right, let's talk about the climatic controls that shape weather patterns in any given area. There are 6 major factors to consider here. First, latitude plays a crucial role because it determines how much sunlight a place receives, which directly influences its climate. As you move away from the equator towards the poles, temperatures tend to drop. Next, altitude or elevation is key. Higher places generally experience cooler temperatures, even if they're closer to the equator. Then, we have pressure and wind systems, which help distribute heat and moisture around the globe, affecting everything from rainfall to temperature variations. Distance from the sea is also important because coastal areas usually have milder, more stable climates compared to inland regions, which can experience more extreme temperatures. Ocean currents, which transfer warm or cold water across vast distances, can significantly modify the climate of nearby landmasses. Think of how the Gulf Stream warms parts of Europe. Finally, relief features, like mountains and valleys, influence local climate conditions by affecting wind flow and precipitation patterns. So, when we look at a region's climate, understanding these 6 controls helps us see the bigger picture and how interconnected these factors really are. Let's take a closer look at the factors that influence India's climate. First, latitude plays a significant role. India is roughly located between 8 degrees N and 37 degrees N, and interestingly, it's divided almost into 2 equal parts by the Tropic of Cancer. This division impacts the amount of sunlight different parts of India receive, which in turn affects the climate patterns across the country. Next, altitude is another key factor. Typically, higher altitude areas tend to be colder because as you go higher, the temperature drops. But also, coastal locations tend to be cooler during the hot summer months and warmer in winter compared to inland areas at the same altitude and latitude. This is because of the moderating effect of the ocean. Finally, pressure and wind conditions are quite unique over India. During winter, there's a high-pressure area north of the Himalayas, which causes cold, dry winds to blow towards the lower pressure areas over the oceans to the south. Conversely, in summer, a low-pressure area develops over interior Asia and northwestern India, influencing the monsoon winds and bringing heavy rainfall. All these factors, latitude, altitude, and pressure systems, are interconnected and play crucial roles in shaping India's diverse climate. Understanding these helps us see why India experiences such a wide range of weather patterns across its vast territory. The climate of India is heavily influenced by the monsoon winds, which play a crucial role in shaping the weather patterns across the region. Interestingly, it was the sailors who first observed this phenomenon back in historic times. As they traveled to India by sailing ships, they experienced the winds at their mercy and noticed that these winds would reverse direction seasonally. This reversal was a vital clue to understanding the monsoon. The Arabs, who were also traders visiting India, gave this seasonal wind reversal a special name, the monsoon. This term has since become synonymous with India's climate and agricultural cycles. Recognizing how these winds change direction is key to understanding India's weather and its impact on farming, trade, and daily life. So, in the context of our overall theme, the monsoon isn't just a weather pattern. It's a fundamental part of India's history, economy, and environment. It's fascinating how early sailors and traders played a role in identifying a natural phenomenon that continues to shape India to this day. Now, let's talk about the onset of the monsoon and its withdrawal. The withdrawal, or the retreat of the monsoon, is a process that happens gradually. It doesn't happen overnight. In fact, it begins in the northwestern states of India by early September. This gradual retreat is important because it signals the end of the rainy season in those regions. By mid-October, the monsoon has completely withdrawn from the northern half of the peninsula. That's a significant milestone, marking the transition from the rainy season to the dry season in those areas. Interestingly, the withdrawal from the southern half of the peninsula happens much more quickly. It's a fairly rapid process compared to the northern regions. Understanding this pattern helps us appreciate the overall climate cycle and how it influences agriculture, water resources, and daily life across different parts of India. It's a natural, yet complex process that plays a vital role in shaping our weather patterns. Now let's talk about the cold weather season, which is also known as winter. This season typically extends from December through February. During this time, the vertical rays of the sun shift towards the southern hemisphere, which has a significant impact on the climate. As a result, North India experiences very intense cold weather, with temperatures dropping quite low. However, it's interesting to note that in South India, this season isn't as clearly defined, and the temperatures don't usually drop as sharply. Another important point to remember is that, occasionally, tropical cyclones can visit the eastern coast of India during this period. These cyclones are powerful storms that can cause heavy rains and strong winds, adding a different dimension to the winter weather pattern. Connecting this to our overall theme, understanding these seasonal changes helps us grasp how different parts of India experience varied climates, which is essential for planning agriculture, tourism, and disaster management. The winter season, with its shifting sun rays and weather phenomena, truly highlights the diverse climatic zones across the country. Now let's look at slide 16, which covers the hot weather season, or summer. This period typically runs from March to May. During this time, you'll notice that the vertical rays of the sun shift towards the northern hemisphere, meaning the sun is positioned more directly overhead in the north. As a result, temperatures start to gradually increase from south to north across the country. In particular, the highest temperatures are experienced in different states at different times. In Karnataka around March, Madhya Pradesh in April, and Rajasthan in May. This variation is linked to the gradual northward shift of the sun's direct rays and the warming trend that accompanies it. Understanding this seasonal pattern is key to grasping how climate influences regional weather and agriculture across India. It also helps us see how the sun's movement directly impacts temperature variations during the hot season. The rainy season, also called the advancing monsoon, typically runs from June to September. During this time, the intense heat in northwest India causes a low-pressure area to form. This low-pressure region acts like a magnet, drawing in moist winds from surrounding areas. As these winds converge, they bring heavy rainfall, which is essential for agriculture and water resources. However, sometimes after several days of consistent rain, the monsoon can suddenly pause. This pause is known as a break in the monsoon, and it can last for a week or even more. These breaks are a natural part of the monsoon cycle and highlight the variability in weather patterns. Overall, understanding the timing and behavior of the monsoon helps us better prepare for the seasonal changes and their impact on our environment and livelihoods. Let's take a closer look at the distribution of rainfall across India. As you can see, the western coast and the northeastern parts of the country receive very high rainfall, exceeding about 400 centimeters. This is primarily due to the monsoon winds hitting these coastal regions directly, bringing heavy rains. On the other hand, if we move to western Rajasthan and the adjoining areas of Gujarat, Haryana, and Punjab, the rainfall drops to less than 60 centimeters. These areas are much drier because they lie in the rain shadow region, away from the direct influence of the monsoon. Similarly, the interiors of the Deccan Plateau and regions east of the Sahyadris also experience relatively low rainfall. Understanding these variations helps us see how geography and monsoon patterns shape India's diverse climate and agriculture. So let's talk about the climatic influences of the Himalayas. These majestic mountains play a crucial role in protecting the Indian subcontinent from extremely cold winds that blow in from Central Asia. Because of this, northern India tends to enjoy higher and more consistent temperatures compared to other regions lying at similar latitudes. It's like a natural shield that moderates the harshness of the cold winds. Similarly, the peninsular plateau benefits from a different kind of climate moderation. Being surrounded by the sea on three sides, it experiences moderate temperatures throughout the year. The presence of the sea has a balancing effect, preventing extreme temperature variations. Now, an important concept to highlight here is the influence of the monsoon. The monsoon is like the heartbeat of the Indian climate. It unifies the entire subcontinent. Its seasonal winds bring about a predictable cycle of weather patterns. The seasonal change in wind systems, shifting from dry to wet and vice versa, creates a rhythmic and dependable cycle of seasons that define much of India's agricultural and cultural life. Connecting this to our overall theme, understanding these climatic influences helps us appreciate how geography shapes the climate, which in turn impacts the livelihoods, agriculture, and even the cultural practices across India.